Hello friends, welcome to our channel Techcorner English, where we break down the complex topics into easy to understand pieces. So today we are going to discuss about why DC is used in electronic circuits. Mainly if you see like any electronic like PCBs, boards or electronic devices, TV, television, LED bulbs, everywhere we are using DC, not AC. I hope you would have also thought about this, like why it is, or if you haven't thought, you can think right now. And today we will be giving you the exact reasons why we are using DC instead of AC. So that's what we are going to see in this video. Before starting, please do subscribe our channel and press the bell button so that you will get the video as soon as we post it. So let's start. See, that's what we are going to see from slides. So why DC is used in electronic circuits instead of AC. So let's understand basically what is the difference between DC and AC. DC means direct current and AC means alternating current. So from the name itself, it is like DC, direct current, it is a direct current, whereas AC, it is an alternating current. So DC is always a constant supply, whereas AC is fluctuating sinusoidal supply. So that is the main difference as well. So that's what even mentioned here. DC is a type of electric current flows in a single direction, maintaining a constant voltage level, whereas AC is characterized by its periodic change in direction, resulting in fluctuating voltage level. So this is the basic difference at the AC and DC. And if you see even the waveform, if you can see the direct current as a straight line, right? You can see a straight line direct current, and AC as a sinusoidal, where it is going upwards to a peak, then coming downwards, then going to the negative phase, then again going. So it is crossing zero at multiple times, and that is what like frequency is determined. So although this is a direct current which is constant, or AC is sinusoidal which is not constant. So that's what even mentioned here. DC flows in one direction and constant voltage level, whereas AC alternate directions periodically, voltage level rises, varies sinusoidally. So this is the main difference, and this is the main reason also for why it is not used in DC electronic circuits. That's what we are going to see in next slides. So DC provides a steady voltage, so there is no confusion regarding that. DC provides a steady voltage, and that is the first thing why we are not using AC is this constant voltage. DC delivers a consistent voltage, essential for many electronic components. So we know like there are many electronic components, basic things like resistors, capacitors and LEDs. So all these devices actually work with DC better, or the few devices are only compatible with DC. So whenever we use a AC thing, then we need to convert to DC wherever we want to use this capacitor or resistors or whatever it is. So which for any electronic components we need that constant voltage. And the second one is component function. That's what even I told you. So components, like there are microcontrollers, PLC programmings and transistors, which actually require a stable voltage to operate correctly. Otherwise you know that like these are all highly sensitive devices. Even a small fluctuation in the power can erase the data over it. So we need a precise consistent voltage. So that actually provides by AC, not by that provides by DC, not by AC. So that is also another reason. And voltage fluctuation, AC, as we discussed, it is fluctuating in nature and which is unpredictable behavior, which can create a potential damage to sensitive components. So basically this is what we already discussed. DC is compatible with most electronic components. DC is compatible with most electronic components. If you see resistors, capacitors, LEDs, so all these things works in DC very perfectly. And because of all these things, it has a constant voltage, predictable nature, which works with all the electronic components. So this makes a simplified circuit design. If you design a circuit in DC, it is very simple design which we can make it. So that's what even the another advantage. DC constant polarity simplifies circuit design and which reduces errors. So components also will operate predictably with higher efficiency with a consistent DC power source and complexity. So since DC, we are using the DC, we don't need to convert every time from AC to DC, which is again like a complex thing, or which can create a more losses as well. So which also is reduced to a higher extent. And the next most important thing is that DC supports efficient energy storage. If you see any batteries, the inverter batteries or whatever it is, capacitors, so everything is stored by DC. So DC makes it more easier to store energy, even if for battery or even for capacity. So battery, as we know, it stores chemical energy and converts into electrical energy. That is DC. The battery provides us DC, and capacitor stores electrical energy in the electric field. So wherever we need an efficient energy storage, there also DC is more efficient. And DC reduces noise. As we know, it is a consistent or constant voltage without any fluctuation. The chance for noise is very less, whereas AC it is very high. So that makes it more crucial for sensitive electronics, and that's the reason we are using DC. So coming to the conclusion part, so if someone asks you why AC is not used in any circuits and DC used, this single slide you can just go through and you can explain them. All the points are covered in this single slide as well. And now you may have another doubt, then if DC is so much of advantages, then why we are going for AC? Why don't we get DC in our home, so that we don't need to do any conversion, we can directly do. So I will just tell you the reason at the end of this video for that. Before that, let's see why DC is preferred. So steady voltage, I don't think there is any confusion. DC provides a stable source for sensitive components. And component compatibilities, that's also we discussed. It is most of the electronic components are compatible with DC. And all these reasons we can have a simplified design with the DC, which reducing complexity and errors. And storage, if you want to store the energy, so DC is more efficient, even if for battery or capacitor, so backup power and voltage smoothing, so whatever, so DC is more efficient. And noise reduction, DC since it is steady nature, minimize electrical noise, which improving the signal integrity and the quality or the efficiencies, for in simple words. So these are the things why we are using DC in electronic devices. And coming to the last question, why then we are using AC? As we see, like, these are the advantages of DC. There are some disadvantages of DC, and which like are the advantages of AC as well. So that is the reason we are not using that in any transmission or distribution system. Anyway, we will be making a video on this, why transmission system is in AC not in DC, and why what are the difference between AC and DC as well. So these two contents we will be making soon. So please do subscribe and support our channel. More such contents with more interesting facts, knowledge will be coming soon. So please do subscribe. Thanks for watching. Thanks for supporting us. So see you in the next video. Thank you.